So welcome to today's webinar. My name is Matthew McKnight. I'm a technical specialist at Autodesk, and today we're going to be looking at large assembly management for Autodesk Inventor. Now this is the third in what was initially a part one series webinar, but it has been expanded out to three parts purely because there's a lot of content that we've had to cover, and it just wasn't manageable to give it the justice that it deserves. It wasn't manageable to be able to cover all of this in one webinar, so it's stretched out across three. Now in part one of the webinar we looked at, or this series, we looked at a number of different topics specific to large assemblies. We firstly defined what a large assembly is, and we defined a number of the terms and considerations around them. We looked at a number of the most common practices that may impact the performance of when working with large assemblies. We helped you understand a little bit about project planning and file management, how you can go about setting up settings and preferences inside of the likes of Inventor. We looked at visual effects and graphics and the implication of using those, as well as talking about express mode and large assembly modeling workflows. From there we went and we expanded on what we'd learnt in the first session with a lot of theory around things like selection filters and how they can help you improve performance, managing component count, a number of ways that you can do that through to simplifying components, some additional practices that might have been outside of some of these categories that we talked about, and then we started talking about hardware, how hardware can impact your large assembly performance, things like system memory and how you can increase your capacity as well as any additional information. Now, up until today, we've basically just talked a lot about large assembly management. So the part three focus of this webinar series is really about bringing into action some of what we've been talking about. So we're going to go back over some of that information to try and set the scene of why we're actually doing something inside of Inventor. So you've got a little bit of background. But otherwise, we're going to be focused more on workflows inside of Inventor to showcase some of these methodologies and practices that we were talking about. In this instance, we'll talk about what are large assemblies. We'll redefine those and showcase an assembly that we'll be using today. We'll talk a little bit about project planning and file management, some of the preferences and settings you can set up, go through your large assembly methodologies, including reducing component count and complexity of parts, how view reps and LODs are relevant. We'll look at express mode as a way of speeding up your workflows of using large assemblies, and then how you can work with drawings as well as any additional information. Now keep in mind that this webinar is sort of about an hour long. The reality is that I'm picking and choosing some content that I think is relevant, and some of which is a little bit easier to sort of show in a webinar rather than getting too bogged down in the details. The reality is I'm only showing a small snapshot of what could be a problem with your large assembly performance. Okay, so at the end of this webinar, I'm not going to show everything that you need to do that's going to significantly improve the performance of your large assemblies. I'm going to show you some things that can help you do that. But the reality is that there's more often a number of different things that could be impacting the performance, and some of those are outlined in the diagram you can see on the screen now. Otherwise, let's try and jump straight in by looking and redefining what a large assembly is. Now, it's not uncommon for me to see large assemblies and what it almost categorizes as very large assemblies here in Australia. More recently, I've seen customers in Australia that have got assemblies exceeding 100,000 occurrences and exceeding 10,000 unique parts. I won't say that there's lots of customers like that, but there are lots of customers with high component counts. But the question is, does this necessarily mean that it is a large assembly? Sure, in that case, it probably is going to be a large assembly if it's got an excess of 100,000. But just because you've got a high component count doesn't necessarily mean that's the only reason it could be a large assembly. Because a large assembly could be more commonly defined as any assembly that has some sort of adverse performance effects when using it. When we say using it, we're really talking about load time. So does it take a long time for them for a file or an assembly to load or a drawing? Do you get memory errors or low memory errors popping up? Do you get graphics performance? Maybe you're trying to rotate and you're getting a slow performance when it comes to that. Or is it difficult for you to create drawings, maybe to open drawings, to modify drawings, to place views on drawings, etc., etc. These are all indicators of what a large assembly might be. Now, the reality is, and like I tried to define before, there is numerous areas that could be impacting the overall performance of your large assemblies. It could be simply the fact that you've got a lot of information. You've got a lot of components, both total occurrences or unique files that impact the performance of your assemblies. The other things, though, could be simply the complexity of the geometry, and I'll try and highlight in the assembly that we're just about to show you that if we were to model it a certain way, we could quite easily consider a large assembly, but because we've used certain modeling techniques, and significantly reduced the complexity of that design. It could be the way that you've used certain modeling techniques, such as using numerous level of details within inside of a drawing. It also could be down to the hardware and system that you're actually using when working on large assemblies. So any of these could impact quite significantly the performance of Inventor when working on large assemblies. Now, the assembly that we'll be using is probably slightly smaller than what we'd categorize as a large assembly if we look at purely the total number of occurrences or the unique parts within inside of that assembly. But the reality is that this part could quite easily be a large assembly if we hadn't modeled it a certain way. The file is available for download. You can see a short link on the screen there. If you follow that short link, you can get access to the files, and afterwards you can look through some of the information that I've tried to highlight in today's webinar as well. So let's have a quick look at this file. Now, we're running 2019. We're lucky enough to have been able to install 2019 in the last few days and record a lot of this information to show you this. But you can see here it's reasonably typical for an Inventor user in Australia and New Zealand. Medium-sized fabricated structure with steel, fabricated sheet metal, welded parts or sub-assemblies with structural components, bolts, fasteners, and the likes. And you can see here the component count and the unique parts down in the bottom right-hand corner of the screen if you're wondering what they are. This is really, an ideal assembly. It's a material handling assembly that we'll be showcasing today. So let's talk a little bit then about project planning and file management. And one aspect of that discussion that we had is around things like your content center and managing content center data. In an ideal situation, what we were trying to do is more commonly what people do is they basically load all of the content center libraries up, and they start using the way that it comes installed by Inventor. The reality is if you're struggling with large assembly performance, one of the best things you can do, or one of the first things you can do, is look to try and reduce the size of your content center, because the database that comes installed has in excess of 750,000 components, and that may be unnecessarily loading potentially hundreds of thousands of components when you go to use the content center. So what we try and do is try and create your own content center library and copy over the components that are relevant to you into that library, and then turn off the other ones that are no longer relevant. So how do you do that? Well, inside of Inventor, we can do that. We don't have an open document. We can go to our Projects tab, and you'll see a little icon down in the bottom right-hand corner, sort of hidden away a little bit. But this will open the configuration area for the content center data, where we can go in and place a display name. And using that display name, you'll notice that we've got read and write access beside it. So we can then go and configure this as required. Now, I've turned on the other libraries so that we can see the categories of components that are available with inside of those, and specifically choose ones that we want to insert. Now, I've opened up an assembly to then expose the ability to be able to edit the content center library, where we can go in and specifically narrow down to, say, a standard or a category of components that we want to look at. I'm using merged view here, which will show all of the standards that are available. Now you'll see if I click on any of those categories, I can copy to the large assembly content center that I've created. But the problem is that with so many different standards chosen, and even though I've narrowed it down to the hex head bolt category, there is still the better part of maybe 50 or 60 different standards of hex head bolts that it's trying to copy over, and it took in excess of 3 or 4 minutes to be able to copy all of those over. So a better way of doing that even is to maybe narrow down to a specific standard or group of standards that you're looking at. So maybe in this instance we narrow down to the ISO standard and then grab all of the hex head nuts from the ISO standard and insert those into our own content center. And you can see here that happens much quicker, so it's copying much less data. Even better again is to choose inside of one of those standards the individual standards that you might need. In this case we're going to choose all of the Australian standard flat washers, but you might choose to choose an individual standard. Maybe you're only using a specific standard of flat washer with inside of there, and you can do away with all of the other ones. One way or another, the idea is to try and minimize the information we're including inside of this custom content center. And after we've done that, we can then go and turn off the other libraries that are available to us, just leaving on our own library, in which case what you'll find is when you go to place a component from Content Center, you're significantly cutting down on the number of components that is necessary to load as part of that process. And you can see here we're given access to just those components that we'd previously configured. You can see this is like a good, better, best methodology. Try and remove down to just the specific categories inside of a category, narrow down to specific standards, and even down within inside of those are there even fewer standards that you can select. So that's a good starting point, is to start at looking to set up Inventor with libraries and templates and all of these sorts of things that try and minimize the demand on the system to load a lot of this information into system memory. Furthermore, another thing you can do is spend some time working on preferences and settings. Now there's a number of different areas that we spoke about in the last webinar in terms of your settings. These are inside of the application options, where you can go in and set up everything from general settings to document specific, say part, assembly, drawing, right down to sketches and even colors and display styles inside of the environment. One that I'll showcase, because we are going to look at it a little bit later, is the assembly tab here. We highlighted that you can turn on defer update, make sure that enable relationship redundancy analysis is turned off, and also turn on express mode settings, and we'll talk a little bit about this later on. So how do you do that? Inside of File, Options, this will open up the Application Options area, and you can see we can move between any of these tabs and define or change any of the categories that we want to. Now, recognizing that some of these are going to have very little, if not any, effect on assembly performance, but some of them are going to significantly. So in this case, when we're working with assembly, by turning on defer update, making sure the redundancy analysis is off, and then turning on express mode, and then changing the threshold by which express mode will have an impact on how our large assemblies are handled. The good thing is, once we've defined this, we can export this information out as an XML file that can be then located on maybe a network location and then used across a multi-user environment. So if you've got other team members in your design team, then they need to improve their performance as well, or you want to have a common set of settings amongst users, then they can import your settings into their workstation as well. Something else that you can do as well is to look at unloading any unnecessary Inventor add-ins. Now this isn't one of the first things that you would go and do. This is something that you would do once you started encountering large assembly performance issues, and when you're looking for ways to try and increase the capacity of your system in terms of memory footprint to be able to handle or work with those large assemblies. So the first recommendation is to not go and turn any of these off and just leave it the way that it comes. But if you are starting to encounter performance issues, it's a potential way that you can look to improve your performance. The way that you do that is under the Environments tab. You'll see that under Manage, you've got an Add-ins icon. Clicking this will load up the Add-in Manager. And you'll see here that all of the components or all of the applications that are automatically being loaded or aren't automatically loaded, as well as any that are currently loaded or unloaded from memory. You can see that in the Load Behavior column. So you can go through and choose any of these, maybe the electrical catalog browser I don't commonly use. So I can turn off it loading automatically on startup, and I can even unload it from memory currently in the current session. Now you'll find that this might change. So if I go down to, say, Simulation Frame Analysis, I can turn off load automatically, but maybe because there's a requirement to keep it loaded in the current session, I can't unload it from the current session. And on reloading Inventor, it may actually unload this from memory. So that is another way that you can potentially look to improve your memory capacity when you're working with large assemblies in Inventor. Another thing you can do is to look at your large assembly methodology. And within inside of methodology, there's a number of different practices that can all or each go on to impact the performance of your large assemblies. One of the first that we spoke about is the need to try and reduce the number of components when working on large assemblies. If you've got fewer components, then fewer components need to be loaded into memory. That opens up capacity to load further components or improve the performance of your design. The great thing is the number of tools or ways that you can go about this. Selection filters is a good example of that. So if we go inside of the assembly and we can narrow it down using the filter in the model tree to find the assembly that we're after, inside of here we can use selection filters to try and remove components. Now we're going to use these in conjunction with level of detail, and we'll talk a little bit more about level of details later on. But in this instance we'll create a level of detail that is called simplified, which will enable us to then use selection filters that are available across the top of our screen. And we can go down and choose a variety of different selection filters that give us the ability to be able to choose files, components in numerous ways. You can also access them by holding down the Shift key and then right-clicking in the display area. Now in this instance we'll choose the Select by Size, and we can use a percentage or we can use a dimensional value. And once we've selected the components that we want, we can then go and suppress them, which is what we do in level of detail. Suppressing them will actually remove them from memory. In this instance, we'll need to make sure that when we switch to another level of detail, that we save the sub-assembly or assembly first, because if we don't, then we're potentially going to lose all of the changes that we've made. But you'll notice now when switching between these two states that we have two different variants of our design, one with certain components in it and one without. And this is good when it comes to working with large assemblies, because we can remove a lot of the detail or unnecessary components within inside of a design and improve our capacity to be able to better handle large assemblies. To follow up from this, we'll also create a level of detail at top level assembly called simplified, and we'll change the state or the representation of that sub-assembly to make sure that it is in this simplified state showing the view rep, the same view rep, which was the simplified one that we'd also created. So we're linking the two simplified level of details between both states. Again, remembering that when we make this change, we also need to make save the document to update the change to include the new level of detail that we've inserted, and we can quick and easy switch between the two locations. And you'll notice that the components that we deselected approved for or suppressed are no longer seen. One thing as well, now after you've created this, a good thing is that we can now choose that assembly, and under the options area we can also go and choose to open either the master or the simplified level of detail. So in choosing to load the simplified version, we're not then loading the components that we'd previously gone and suppressed. So if you go on a large or a very large assembly and you remove a lot of unnecessary components in your design in a simplified version, then it could potentially significantly speed up the open time or improve the performance of using that large assembly inside of Inventor. Another area that we can look to is to look to reduce the complexity of parts. And there's a number of ways that we can do this. The Shrinkwrap was an option. But in this first instance, we're actually going to just use modeling techniques. Well, one's a modeling techniques, and other is a visual representation. So you can see here we've got a checker plate on the right. You can see that it's actually using a modeling technique of a pattern, but it's not inserting the pattern through the entire part, just through part of it. And then in this expanded mesh or perforated mesh, there is a visual representation that's giving the perforation look, not a modeled feature into it. So let's take, in this instance, this grate that's on the bottom of part of our material handling equipment. And what we'll look to do is first, let's look at the file size to begin with before we modify anything. So it's 843, roughly 850 kilobytes. In this instance, we want to look at ways that we can reduce that. At the same time, we don't want to go on and impact the mass or the volume. So what I've done is I've actually overwritten those with the physical mass and volume of the part that I've either measured or that I've calculated using the geometry that's shown using the entire pattern. Now, if I edit the pattern, I can't actually remove any of the individual occurrences, but if I expand out the pattern, you'll notice that I can then go through and choose any individual instances or occurrences of that pattern that I want to suppress. So this gives me the ability to be able to very quickly and easily reduce, in this case, quite a significant number of instances of that pattern. And you'll find that if I then save that document, go back into White Properties, we've already reduced the file size down from 850 kilobytes, or roughly that, to 340 kilobytes. So more than half, we've removed more than half of the file size just with that simple file change. Again, remembering that if we were to manually enter the mass and volume, then these would stay the same no matter what we do to the 3D model in terms of changing the representation of the geometry in the part. What happens if we wanted to go even further again, though? And this is where we can use a display style to change the look of the component. In this instance, we could either potentially delete those features, or in this case, I'll just simply suppress them. And we can then use a visual representation or an appearance to showcase the style of part that we're actually trying to illustrate here by putting the cutouts in the part in the first place. You can see here by changing the display to an expanded mesh that we can showcase the part actually has some transparency to it. Now, the quality of the outcome of this part, I find, is a little bit dependent upon the geometry of the part. So when you think of a component like this, you're actually going to have a top and a bottom side, which means that the display style actually comes through both sides, and you'll see the underside in the top side. Now, inserting these is very quick and easy. You can change, you need to understand there's two aspects of this. There's the top, which is showing the texture, and there are textures that are included with Inventor. They're located in this folder structure here, C, Program Files, Common Files, Autodesk Shared Materials, Textures, Mats. And inside of here, if you do a quick search for anything that's got an associated cutout file, then this is the type of file that will give you this translucent or transparent look. So I'm going to narrow it down and say, well, I want to use, say, screen 4 because it's got the two components. I'll use the top image here to depict the style that I want to be visual. I'll give it a scale. And then I'll go into the cutout section in this style, change this to the associated cutout pattern. Again, change the scale of those and hit OK. And you'll find is what we've been able to do is create a quick, semi-transparent representation of our part that looks like a transparent mesh. Again, this is somewhat dependent upon the geometry of the part and even the type of image that you're using to represent the part. But the good thing is is that you'll notice here by using this where you can significantly again reduce the file size. So now we're down to about 160 kilobytes. So we've gone from circa 850 to 160 with a couple of small changes. We've still got the same material weight and volume because we've manually overwritten that. We potentially could replace that with a custom material that could do this. But you'll notice there's a couple of different modeling techniques that potentially can go on and flow on to have an impact in your design. And pause for a moment and think, well, what happens if we hadn't have used that? How would we have displayed it? Potentially, we would have had to have displayed it as a note on a drawing, or we can use a visual representation or a visual cue here. Or in some instances, like I've said before, people will model in the full detail like they do with threads and so forth, but that can add significant requirement to the capacity of your system to be able to handle, and that could quite easily turn what is a relatively easy assembly to work with inside of in Inventor into a very difficult one. The next thing we want to talk about is level of details. And level of details are an interesting topic because they really come about in the days of 32-bit systems. So we're probably talking 5-7 years or more ago, where level of details were relevant because of the available system memory to be able to run applications inside of Windows. Since the introduction of 64-bit systems, where it's not uncommon to see 16, 32 gig of memory available, or potentially even more, that it's a little less relevant than it is nowadays than what it was previously. Nonetheless, they can still be used to help you use large assemblies by removing files from memory or components from memory and significantly reducing the overhead required of your system to be able to manage and work with large assembly data. Some do nots. So, what shouldn't you do when using levels of details? Well, the idea of a level of detail is that in switching between level of details, you're actually loading and unloading components from memory or subassemblies from memory. Recognize, though, that during that process, you're actually, because of that load and unload process, that there is some time associated with doing it. So if you're working with inside of a very large assembly and you're switching, you will have a delay in time that it takes speed up in moving between one level of detail and the other. Also, when it comes to working with shrink-wrap substitute files, this can also impact your performance because a shrink-wrap substitute file can be quite a large file. You're combining all of the information of a subassembly into one component. But having said that, that might be a trade-off because the subassembly is complex and you've been able to significantly reduce the detail of that subassembly in either the component count or the modeling detail of the files. And the other thing to keep in mind, and this is something that's critical, is to try and, where possible, avoid the use of multiple level of details inside of a drawing. The reality is every time that you use a different level of detail inside of a drawing, it loads an additional assembly into memory in the background that it's managing. So the idea is to try and avoid this and where possible use, say, view reps in place of level of details to avoid that. When should you use them? When you're working with reduced memory. Maybe you don't have a lot of memory, or maybe the large assembly that you're using is using so much memory that you're starting to run low on it. Then potentially start to look to use it then. You can use a level of details to help you remove intellectual property on files that might need to be shared outside of your organization. It can also be used in certain instances where you're trying to configure a family of parts where certain components are suppressed based on a specific configuration of those designs. So let's have a look again at what that workflow looks like. Now, we've shown some of this workflow before, but we'll go over it again. You can expand the representations folder and you've got the level of detail option there. You right click that and say new level of detail, and we simply slow click it and rename. Now in this instance, we're doing that in the first place because we're going to simplify some of the other designs. We've opened a subassembly and we've turned off a lot of the construction geometry in there, so planes, axes and so forth, because again they can unnecessarily add to the system's requirement to load into memory and impact our performance on large assemblies. And likewise, we've created another level of detail, again called Large Assembly. So we're matching the names where possible and giving an explanation of what they are. And then we're using some of our selection filters to then run around and find parts or components within our design that we can suppress. Now, remembering, by suppressing the component in a level of detail, we're actually removing it from memory, or we're avoiding it loading into memory. In this instance, we need to save it. It's critical. If you don't save it and you switch to a different level of detail, it won't be retained. And then we'll go and find another sub-assembly that we want to change as well. And we can do that with inside of this one here. We'll, again, create another level of detail with the same description, and using, again, some of our selection filters, we'll then go and choose specific components. We'll use the same technique as what we used before, choose based on model size and suppress those components, but we can also go around and select groups of components as well and simply suppress those individually if need be, to narrow down the component to the state that we actually want to be able to see it in whilst working inside of this environment. So retaining the information that we think is necessary. We'll save it and then exit. And then once we're back inside this environment, we need to then make sure that the level of detail that's being referenced inside of this top level assembly when we switch to the large assembly level of detail matches or coincides with the one that we want represented for each of those sub-assemblies. So we're simply just going to go and change them. We hit save now, which would save the document and any changes that have taken place to our design. And then theoretically we can switch between those. And you'll see that by switching between these, any sub-assemblies that we've defined level of details to, and we've then simplified by reducing component count, will effectively load or unload those components from memory. And as we saw a little bit earlier, when it comes to opening the document, then be given a choice about what level of detail, what view representation we're actually then loading into memory. The next thing we can do is we can also look at Shrinkwrap as well. Now, Shrinkwrap is a way of us being able to take an assembly, a sub-assembly even, in this instance a sub-assembly of complex components, a mixture of different bits and pieces with various different downstream components contained within that, and package this into a representation that can be used, or a substitute that can be used in place of the existing assembly at a level of detail level. We simply do that by right-clicking on our level of detail, going into Shrinkwrap, and then choosing the options based on what we want to do. We can link this to a design view or a level of detail if we've got an existing one. We can choose components based on size, similar to what we've seen previously. We can individually walk around and choose components based on a style or a component group. And if we over-select or we choose something we realize, hang on a tick, we shouldn't have selected that, we can then go and change that from excluded to included. If we move to the features, we can actually go down to a feature level. So in this instance, we can choose features based on holes, pockets, fillets, and chamfers. And based on the selection criteria that we've defined there, when we check preview, that'll actually show that it'll remove whatever detail that we've pre-selected there. So including the holes which we had selected. Now we've chosen to deselect those, but you'll notice that the bits of angle iron now have square edges on them. That's because the fillets have been removed. We can create the document by choosing a template, a file name, a BOM structure. We can define the way that it's going to combine all of these solids and any other settings that we want, and hit OK. In doing so, what it's going to do is, in this instance, create that substitute level of that shrink wrap, which can be used as a substitute level of detail to represent the design. Keeping in mind that what it's doing is combining all of this information together and removing any of the detail that we've specified. In which case might impact the initial file size of the part, but potentially overall reduce the requirement to load all of the other components into memory as well. Now, view reps is another area that we can use, which are different. They're a type of view or a representation of our design, but they're not the same as level of detail. And they offer different set of advantages and disadvantages when using them. When you load a view rep into memory, it loads all of the components that are required based on the visibility of the component. But the interesting thing is that when we switch between several view reps, what in essence happens is that any component that has been loaded into memory stays loaded into memory. So if you switch between numerous view reps, what you'll find is potentially over time more and more components are being loaded in memory. The only way of unloading those components from memory is to close the document and then reopen it to the view rep that you want to, which you've got the option to be able to do as well. The other good thing here, and unfortunately I forgot to include it in as part of the video, is that you can actually create a view rep from a level of detail. So if you decided, well, actually I want to use a view rep as part of a drawing, which is based on a level of detail, you can right-click the level of detail and then say copy to view rep, in which case it would actually do that. So let's have a quick look at this process. Here we are inside of Inventor, and we're working on the same assembly as what we've done before, but under the representations we've got view. We can create a new view, and in this instance we'll call it tail components. And what we want to do here is create a view rep that just shows the components in a specific area of our design that we'll use to then document as part of a drawing. Remembering before we said, where possible, avoid using any more than one level of detail. So in this instance, in place of level of detail, we'll use a view rep. Now, as we said, a view rep enables us to, in a similar fashion, be able to narrow down the components and parts of focus. So in this instance, rather than suppressing, though, we're going through and changing the visibility of those components. And in this instance, because we've grouped, which is another good practice to have, is to group hardware together, we've simply right-clicked the hardware folder and it's suppressed any standard components that we have. If we were to save that design, then we're really pretty much sort of ready to then move into a drawing. The only recommendation we might do is to close, if we wanted to create a drawing of this view rep, is to close the assembly, reopen the assembly with just the view rep that we're interested in doing a drawing view of open, and then creating that drawing based on that, because then it would avoid all of the other components loading into memory as well. Next, let's look a little bit at Express Mode. And Express Mode, I can't remember exactly when it came out, but it wasn't all that long ago. But Express Mode is a way of working with large assemblies that helps models open much faster than loading them fully or full into memory. It only loads the information that's necessary. It's in essence, it's loading a cached version of the graphics into memory. And as required, it will load or fully load components that are required for any data or command requirements based on your usage. It's not uncommon to see performance improvements of somewhere around sort of 3 to 5 times in terms of file open times. So you can save significant time when it comes to using Express Mode. So keep that in mind. But also recognize that the Express Mode data is actually attached to the file. So you need to make sure that you've turned Express Mode on first and the file has been saved to include the Express data to actually take advantage of the performance improvements of using Express Mode. Let's have a quick look at this. So in this first instance, we'll just open the assembly we've been working with, and you'll see that by default it's going to want to open in full, but we've got the option to be able to quickly change that to Express if we want to. Now, in this instance we won't. We'll just leave it the way that it is. The good thing is that we can work through and choose any of the view reps or the level of details that we had previously selected to open, and we'll open this up. And it takes about 5 or 6 seconds on my laptop to be able to open this assembly to a point where I can start using it. It's not very long at all. And that might be partly because we've gone through the process of designing this part using simplification techniques and simplifying it using levels of details to actually speed up the process. If we go into our application options under the Assembly tab, Again, we need to make sure that Express Mode is turned on. This will actually save the graphic information within inside of the assembly file, so you need that in the first place. But the other reason why it didn't automatically open in Express Mode is because the threshold by which opening an assembly wasn't met. So we can lower that threshold, and now you'll find that because we've got more than 300 unique components, it will by default want to open that assembly in Express Mode. You'll note that I don't have the option in this instance to choose the view rep or the level of detail, so it's going to open the last one shown. And what I can do now is open. You'll see here it actually displays to us saying that it's opening Express, and you'll see that there is some time saving in even a file size of this size in opening that assembly, let alone a large or very large assembly. If you want to load full, you can do that from the assembly menu. Just click on the load full icon, and that will then load all of the assembly, including components, into memory in a full status. Remembering that, that this will happen automatically if needed as part of the process of working on this design. Okay, finally, what about drawings? Now, drawings, there's a number of things that we spoke about that you can do. Things like enabling background updates to happen in the background, specifying a simplified drawing view before and the level of detail before opening the model file. You can click the document tab of the respective model to activate the appropriate document. You can avoid or reduce the use of property overrides. You can purge any unused drawing styles, and obviously try and keep your file size to a minimum. But what and that includes, the number of sheets and the number of drawing views placed on each of those sheets. But let's have a quick look at a simple workflow you could use when working with a large assembly document. In this instance, we've loaded an assembly, and we've loaded in the state that we ideally want to display in our drawing view. You'll notice that if we go inside of document settings, we can go into the document settings of this individual document and change some specific settings. In this instance, defer updates and the way that shaded views are displayed. Now, ideally, you would save this as part of a template, so you would use this as a template. But the one thing you'll note that by turning on defer updates, it actually stops us from using the place view commands. So what we need to do is turn that off, and we can by just right-clicking the drawing top icon, and you'll note that we now have the drawing views available to us. Now, what we can do here is we can go through, and like I said, it'd be best to have the assembly loaded in the level of detail that you want, and we have, to save the need to change this when we get in the assembly environment. But you'll notice here that a couple of things. I'm pre-configuring as much information as I can before I place the drawing view. The drawing view is hidden, so I've actually just got an outline of where the drawing view will go. And now I can place that drawing view. And the other thing I'm doing is I'm only placing one drawing view. So a good practice to try and over placing drawing views is to place one drawing view. Can I place the information that's necessary on that individual view, or do I need to create any additional views? Now, in this instance, I might need to show the length of the unit, so I need to show another drawing view to show the length. I might need an isometric view. Maybe I'm going to put a bill of materials on here and a group of balloons as well. But to show the key assemblies or sub-assemblies of this design. But the reality is you want to try and keep as much of this information as minimal as possible to try and avoid the size of the document. Now, that might be unavoidable. You might have to do a sales drawing, and the sales drawing might need to include a specific part of the design, like the tail components that we'd previously created. So in this instance, we've created a second view. Again, only when necessary. We're creating a view on that, a second drawing sheet, and a view, only the view that we need. Again, if we need any secondary views from that, then we create those individually as required, so rather than creating 3 views up front. And then from this, then we can put in place a bill of a parts list. So we'll place the parts list on our drawing. We'll choose the document that we're going to refer, or we could select the drawing view and simply go OK and place this. Now, the funny thing you'll notice here is that it's bringing over all of the information. It's because we're using a drawing view, a view rep in this instance, it's actually including all of the other components that aren't visible but are actually loaded in the background. So what we can do is we can change this by adding a filter to the parts list and filtering only components with inside of that view rep, which is not possible with inside a level of detail. So it's only possible with a view rep, and then changing in this instance the item numbering with inside of this design to reflect the items only shown with inside of this drawing view of the components that are only visible on this design. And I'll simply and quickly rescale this. So what you can see here is we're really just trying to, where possible, trying to minimize the information that we're putting on there. We're using simple workflows for how we place our components. We're using view representations where possible in place of level of details, where possible even trying to avoid or minimize the use of those where possible. And you'll notice that one thing that happens is that if we change now our drawing sheet to defer update, if we then go back into the assembly and make a change to our tail components view rep, so in this instance we hide that tail component, one of the components with inside of that view rep, a couple of things happen. The parts list did update, and updated very quickly. You had to watch very closely, but you'll see that one of the components in the views didn't. This was a mistake by me that I noticed afterwards, and it's because I didn't link that view to the view rep. This is an important or critical component. We need to make sure that if you want to maintain that relationship, that you do link that in the first instance. And you'll see now that once we've done this, we've updated our drawing. The drawing views and the parts list will be updated. And we could, if we wanted to, this is very large assembly, we could now turn off or turn on defer updates. We could work away on this drawing, work back with the assembly, make a number of changes, come back to the drawing, keep on working on it. And then it wouldn't be until we actually turn defer updates off again that those updates would flow through to the drawing. So again, another practice to help you improve when working with large assemblies inside Inventor. So finally, let's try and wrap all of this up, some additional information. One thing we really haven't mentioned in all of this series is the relevance of using some of the more recent updates of Inventor. It's not uncommon to go out there and find a company that is standardized on using, 2, 3, or possibly even older versions of Inventor. But what I would recommend is if you're encountering large assembly performance issues, look to some of the newer versions. In many cases, lots of customers have access to those. They're paying maintenance, or they've got a subscription which would give them access to the latest updates. Simply looking to, say, Inventor 2018, and in 2018 had a number of performance updates to it, both working with large assemblies, the assembly files themselves, but also drawings as well, and working with drawing performance. You can see those on the left. But 2019 as well, which has just recently been released from embargo, and we can find some information. You should be able to find that if you do a quick Google search about some of the new features and functionality. Also includes a number of performance enhancements when working with assemblies inside of Inventor. Another area that we really haven't spoken too much about is data management. And data management is another critical area for a number of reasons. And it can, across a number of areas, can improve the performance when working on large assemblies. Firstly, data synchronization. It's all too common to see inside of an engineering environment local users opening large assemblies across a network. So they're opening from a network location, the data is not stored on their local machine, and that potentially is a large contributor to your large assembly performance issues. The way around that is to use a data management solution like Vault, which would locate all of the files in a central location on the network folder, share this information between various users, but as part of that process, copy the files over to your local machine, ensuring that you get performance enhancements of working on the files locally, but the security of managing those files in one central location. Beyond that, there's also additional workflows such as the copy design workflow that enables you to take an existing design and create a variant of that design by using a workflow that enables you to significantly speed up the process in comparison to manually doing it. So what might take traditionally potentially even hours could potentially take just a few minutes. As well as search capabilities or the advanced search capabilities of Vault. Now, it's all too common to hear from designers and engineers who are struggling to find the information they need because they're using Windows Explorer, say, for example. In this instance, by using Vault, you get advanced search capabilities where you can pull down a variety of different properties that can be used in searches as part of customized search criteria to help you find things, even right down to material properties as a good example of one instance that you could search for. Beyond that, Vault as well, in some of the more recent updates, the 2018 update included some large assembly and drawing performance enhancements, also helps improve the performance handling capabilities when working with large assemblies. So again, try to keep up to date with the changes that are taking place, or at least investigate the viability of moving to the more recent versions of Inventor and Vault as part of that process of troubleshooting any issues that you might be having with large assemblies. A quick summary of what we've talked about today. Briefly, we went over what is a large assembly. We talked a little bit about project planning and file management, some of the preferences and settings and how you can go about changing those. We walked through some examples of large assembly methodology, including how to reduce the number of components in a design, reducing the complexity of parts, view reps and level of details and the impact they have, as well as how you can use express mode and drawings and some additional information about keeping up to date where possible. Like I said though earlier, these are just part of a wide-ranging set of factors that could impact the large assembly performance of your systems. So keep in mind what we've shown today with some of the other things that we've talked about previously that can all contribute towards performance issues that you might be encountering. So how can you get more information, contribute to Inventor and the likes through the tools that you have access to? Well, if you're looking for more information, the Autodesk Knowledge Network is a great place to go and look. Actually, if you look back, most of the information that I've created in this presentation has been, and the previous parts of this large assembly webinar, has been created through the hard work of the Inventor team that have gone together in creating what's new information and large assembly guides when working with data inside of Inventor. So the Knowledge Network is a great place to go to try and find out the latest happenings, new features, new functionality, and things that you can use when working with large assemblies inside of Inventor. The other thing you can do is to Google the Inventor Large Assembly or Inventor Large Assembly Management. Where that's actually going to take you is to some of the help content. And there is a recently updated large assembly best practice. It is quite extensive. Like I said, most of the information that I've put together or compiled for this webinar has actually been based off of, in many instances, copied and pasted into a presentation to capture what broadly the Inventor development team are recognizing as ways of improving the performance handling with inside of Inventor, along with large assembly modeling workflows, some of which we've actually highlighted as part of this process as well. Something else you can do is contribute towards Inventor updates. This can be done in a number of ways. It can be done through the Inventor Idea Station. So if you've got an idea of a new feature, a new function, a new workflow you think would be valuable, you can go on and raise that idea, and you can vote on other people's ideas just as well as they can vote on your ideas. The good thing is that the development team are constantly looking at this for inspiration of new features and functionality, and you'll find, and this includes the most recent release, the 2019 release, that a lot of these new features and functionality actually stem from ideas that have been put on the Idea Station. Another area that you can participate in is the beta program. This is where you can get early access to new releases of the software. So if you're looking to understand maybe what a latter release of the 2019 Inventor product might look like, or possibly even out as far as 2010, then you can, 2020, then you can possibly log in and participate as part of that beta program to get early access to the solutions, provide feedback to the development team to help them improve the quality and the performance of the products. Another thing that you can do is as we've highlighted this, is to try and keep up to date where possible with the new releases of Inventor, which come with a lot of new features and functionality to help you improve the performance of your large assembly handling. The desktop app, which you've probably seen down the bottom right corner of your screen, should keep you up to date with any new availability on new products or new releases of products or new versions of products. So keep an eye out there for your 2019 entitlements. You can also actually access these by going to manage.autodesk.com, where you'll find this information as well, where you can download and then install directly rather than having the automated process of the Autodesk desktop app. Otherwise, I just want to say a quick thank you to everyone who has attended this series. It's turned out to be a lot bigger than I ever expected, so if you've attended all 3 webinars now, I really do thank you for your attending these and your patience and persistence in working through. Hopefully you've had some really good ideas about how you can improve your performance when working on large assemblies inside of Inventor. What I would recommend, if you're looking for some further information, you'll find a lot of information online. So if you're looking to understand a little bit more about what we've been talking about, just do a Google search, and usually the Knowledge Network will pop up as one of the first few results with further information about specific topics. If you're looking to talk to someone, your local reseller is a great place to start. Hopefully you've got their information. If you don't, or you're looking for a reseller, you can go to autodesk.com/resellers, where you can search for local resellers in your area. If you've got some follow-up feedback or questions that you'd like answered, feel free to reach out to me. My details are on the bottom of the screen there. Otherwise, I just want to thank you for your attendance today. It looks actually really nice outside at the moment, so hopefully a good start to the weekend here in Melbourne and around the rest of Australia and the world. Thank you for your attendance. Have a good weekend, and hopefully we'll see you at some of our future webinars. Bye for now.